Okay, we want to use mathematical induction to prove that 2 is a factor of n squared plus 5n for every positive integer n. All right, so to prove something is even, or to prove that 2 is a factor, we need to be able to write the number as 2 times some other number. Okay, so that's, we can do that. So step 1, try n equals 1. And so we're going to say, well, n squared plus 5n, in this case, is 1 squared plus 5, which is 6. And 6 can be written as 2 times 3, so 2 is a factor. Okay, so we want to be able to write it in a form like this, where we have 2 here, and we've got something that's an integer there. Okay, so step 2. Assume it's true for n equals k. Well, then that means k squared plus 5k is equal to 2 times something. So we're going to have to create a new letter. We'll give it 2 times p, so that can match up with your textbook. So k squared plus 5k is equal to 2p, where p is an integer. So now we want to prove that k squared, that k plus 1 squared plus 5k plus 1 is even, but we can use the assumption. Oh god, I can't spell anymore. I'm losing my mind. The assumption, which is this one right here, and this one, kind of both of them. Okay, so we can use this assumption, but we're trying to prove that this thing is true. So let's just start by expanding this out. Let's FOIL, so k plus 1 squared plus 5k plus 1 is of course equal to k squared plus 2k plus 1 plus 5k plus 1. And what we're all going to have to do there is not actually combine like terms. Avoid that as much as you want to do it. Avoid it. We can look and we can say, oh, I'm going to write this as k squared plus 5k plus 2k plus 2. K squared plus 5k we've already defined in the assumption as 2p. So this is equal to 2p plus, here we have 2k plus 2. And then we can go from there and say, okay, I'm going to move over here. This thing is just equal to 2 multiplied by p plus k plus 1. And remember, this thing that we have on the left-hand side is this k plus 1 squared plus 5k plus 1. And this arrow is really kind of going all the way to right there. And this is actually enough. We can say, therefore, k plus 1 squared plus 5k plus 1 is even. Because it's equal to 2 times some expression. That expression is p, an integer, plus k, an integer, plus 1. And an integer plus an integer plus an integer is always still an integer. There's nowhere for a rogue decimal or fraction to get in there. And so that is enough. And so what that means is that if some value of k makes this thing work, then the next value of k, 1 greater than it, also works. And add that to the fact that we know this works for n equals 1, then this thing is true for n equals 1, and therefore it must be true for the next one, n equals 2, it must be true for the next one, n equals 3, and so on, because we've proven that if it's true once, it's true for the next one, and we've proven that it is in fact true at least once, and so therefore we've proven that it's true forever. All right, so that is mathematical induction. That's a really nice one. The even ones are nice. All you have to do is try to get it to be 3 times an expression. Chances are you'll get one. Or sorry, I think I said 3 because I was thinking ahead. 2 times an expression for an even one. Chances are I'll try to get you, is this a multiple of 3? And it'll be a 3 times something. All right, good luck. And, I'm sure there'll be questions, but we'll talk about them.